So just like cylinders are prisms with circular bases, cones are pyramids with circular bases. So the same general ideas apply. Okay, so a definition of cone is a 3D solid that has a circular base and a single apex. Okay, so starting off, let's go ahead and label the parts of this cone. Notice we've got the net of the cone drawn for us, and then the three-dimensional view of the cone. So this point up here we call the apex. It's the apex, the highest point on the cone. This point down here is the center of the base. We just call it the center. This dashed line going across here, well, that's the radius. And that's the same as the radius over here in this, right? So that's, I'm just going to call it R for radius. The line going straight up from the center to the apex is the height, so that H. And then the segment going from the apex to the side of the base of the cone, in both cases, is called the slant height. And we'll just call that L for slant height. So you may want to make a key over here to yourself. H means height. L means slant. We call it slant length or slant height. Let me see what the notes call it. So yeah, you call it slant height. And then R is the radius. Little key for yourself to look at. Okay, so unlike pyramids where we can have all kinds of different shapes as the base, in a cone you only have circles, which means that the formulas can be more specific than for a pyramid. Recall for a pyramid to get the lateral area, we had a bunch of triangles, right? So we just added up all the areas of those triangles. For the total area, we get the lateral area plus the area of the base. Well, because this is a circle, there's actually a formula that will always work to get the lateral area. Pi RL, where L is that slant height. Okay. So I times radius times L will give us the area of this thing right here. Now, one thing to note is that this slant height, which we labeled L, is the exact same as this length over here. And it'll be the exact same as this right here. It'll be the exact same. In other words, this is actually a part of a circle. Okay, so all of these are the same length. So keep that in mind when you're looking at the problems. If you happen to be given some length in here, that's the exact same. That's always going to be the slant height. Okay. Total area. Well, it's the same idea as everything else. It's the lateral area plus. Now, for a cone, we only have one base, so it's the lateral area plus the area of that single base. But again, since the base is always a circle, ¿qué pasó? Found it in here. If John wants. Yeah, we'll do a calculator check today, though. Okay, so area of the base plus the lateral area. Now the area of the base is a circle, so it's pi r squared plus pi r L, that's the lateral area, so we get our total area. And then for the volume, it's the exact same as for a pyramid. 1/3 of the area of the base times the height. Okay, so it's a third of that of a cylinder. Okay. But again, the area of the base is always the same, so we can even simplify this one step further and say 1/3 pi r squared h. Because it'll always be that for a cone. All right. So let's take a look at examples. Okay. So find the lateral area, the total area, and the volume. Now, in order to find the lateral area, we need the slant height. Okay, which that would be this side right here, but we don't have that. Okay. So what can we use to find it? Good. So that's a common theme here, right? We're using that Pythagorean theorem a whole lot. So L, I'm going to call this L, right? The slant height is equal to, now these are our two legs, not the hypotenuse. So the square root of leg squared plus leg squared. Okay. So we get our slant height. Right? So if we don't know the slant height, we've got to find it. And lots of times we can choose the Pythagorean theorem for it. suppose if we would give it an angle or something, we could use a trig ratio, but. Okay. And so square root of 38 squared plus 27 squared gives us 46.615. Now I'm going to kind of show you a handy, I won't call it, I guess it's a trick, but it's a shortcut on the calculator. And in the sense that you don't have to retype all these numbers a million times. So as you're working the problem, you should be doing each part separately and writing it on your paper, but then also you're doing the calculations in your calculator. All right, so 38 squared plus 27 squared. Yeah, I get 46.615. Cool. All right, so our lateral area. Well, the formula is pi RL. And I'm writing down every problem so that I remember it. So pi RL. So pi times our radius is 27, and our slant height was 46.615. I'm writing that on my paper. Then I'm evaluating in my calculator, right? Because I don't know how to do that. Not do that in my head or on paper. So pi times 27 times, and I want to use this number here, but instead of retyping, I'm just going to press the up arrow and press enter. Copies the whole number down. This is why some of you guys, when you check the key, you're off from me by just a little bit and you like freak out. That's why, because I pretty much always do this. I don't type a whole lot of stuff in my calculator. I type as little as I can in my calculator. I'm all about efficiency. So here's my answer, 3954.06. And that is in meters, and it's square meters. So there is our lateral area. Now to get the total area, we need the area of the base. Right, so I'm going to come over here, I'm going to say, okay, area of the base. Well, that's pi r squared, because it's a circle. So pi r squared, let's hear pi times 27 squared. And again, I write that down. Pick up my calculator. Pi 27 squared. And I get 2290.22. 2290.22. All right. So my total area is going to be my lateral area plus the area of the base. Okay. And so let's see, our lateral area we had here 3954.06. And our area of the base we just got is 2290.22. And so I want to add those two together. Now if I type those in, there are, how many numbers am I going to be typing in? Add this up. How many numbers? How many individual digits am I going to be typing in? That's my question. 12, right? So that's 12 chances for me to make a typo, right? Or chances for me to do something backwards, right? A lot of opportunity to make just a mistake that results in a wrong answer, where if I'm actually going to use this for something, I just messed up everything from that point forward. So rather than doing that, I've got both numbers already in the calculator. So I just press the up arrow for the first one, press enter to copy it down, plus up arrow for the second one, enter to copy it down. So now I've pressed 3 buttons, basically. I press the up arrow plus, up arrow plus. It's not that difficult. I press enter, and now I've got my answer, 6244.28. All right, so rather than making a mistake typing something in, I know, assuming I didn't make a mistake in a previous step, that this answer is correct. So 6244.28, and these are also square meters. Okay. Now we want the volume. I'm not even working at the volume. Volume's over here. Volume, and this is really important, guys. 1/3 area of the base times height. All morning I've been working the assignment, and I keep forgetting the 1/3. I get my answer, I'm like, that seems really big, and I remember. Okay, so don't forget. Don't be like me. So 1/3 area of the base times the height. Now the advantage of this is, if we've done it right, we've already found the area of the base, right? We needed that for the total area. And then the height was either given to us, or we probably would have found it right at the beginning. All right, so our height's 38 in this case. So it's just a matter of plugging into this formula. 1/3, 2290.22 times 38. I'm out of space, but You get the idea? And again, instead of even typing in the 2290.22 and having 6 chances of making a typo, I already have that value in my calculator. So I just type in my 1/3 times, look my 2290.22, press enter, times my height, which isn't in my calculator, so I do have to write that 38 in with and we get our answer 29009.5. And that is in cubic meters. By the way, that's a feature of these newfangled calculators. 3 years ago, before we got these, in the 83, you couldn't do that up arrow and copy. You had to retype them. So, yay for technology. All right. So in example 2, we're given the net. All right. So the net, one thing to keep in mind about the net, if we come back over here, the net has a radius and a slant height, but it doesn't show the height at all. So you got to remember that. The net can't show the height. Not possible. Because the height is once you put this thing together, it's this imaginary line coming up. So it wouldn't show up on the net. So we're always going to, if we're given a net, we're always going to have to find the height. Okay? So that's something to keep in mind. So this number right here, this 5, is the slant height. This number right here is our radius. All right, so the radius is the base and our slant height. And so now it may be helpful to go ahead and just, let's draw a little sketch of this cone. So the way you draw a cone is you do the top part of a triangle, and then you draw kind of a circle here at the bottom, and then you do a dashed circle in the back, and there's your little cone. Now the height, again, is an imaginary line. It's coming straight down to that center of the circle, so it's not given. But we do have a radius. We know this bottom right here, we know that's 2, and we know the slant height is 5. And so again, we can use the Pythagorean theorem to find the height. So if we have a net, or if we know the slant height, either way, and the radius, we're going to find the height using the Pythagorean theorem. And notice the slant height is the hypotenuse. All right? And so to find the leg, we do hypotenuse squared minus leg squared. So square root of 5 squared minus 2 squared. And so again, I'm putting this in my calculator so that I don't have to type my calculator. I don't know. I don't want to do that in my head. 5 squared minus 2 squared is 4.58. It's 4.58. All right. Now, let's see. Lateral area. Well, we have a formula. Pi r L. So pi times our radius is 2, and our L, our slant height, is 5. That's given to us. And so we have 10 pi, which let's put the calculator. And you may notice that on the board, I've started using parentheses more than dots, right? And that's because I had somebody in one of my classes came and said, is that, multiple times, is that a decimal or is that a times? And so just to be clear, I'm using parentheses more. I realize that could lead to some confusion. So parentheses, it's the same as times. So pi times 2 times 5 gave us 31.416. All right, now to find our total area, we need the area of the base. So area of the base is pi r squared. We've got pi times 2 squared. And notice again, I'm writing all of this down. I'm not just putting the calculator, I'm not just putting my answers, I'm writing it down. This is part of the showing the work process in the sense that, let's say you did type something wrong in the calculator, and all you put is an answer. There's no way for you or me to figure out what went wrong. At least if you write it down and I see the wrong answer, I go, well, You must have just made a typo in the calculator. So pi times 2 squared, you get 12.566. And so for our total area, we're going to have our lateral area plus the area of our base. Okay. So 31.416 plus 12.566. And again, it's in my calculator, so I don't have to retype all this. 31.416 plus 12.566. We get 43.982. And now my units here. What's that? That's fine. Thank you. You're right. There's the base area. All the assignment problems you have to find the total areas. Good observation, though. Thank you. I did not read the directions. And then finally, volume. So volume is 1/3 area of the base times the height. So we've got 1/3 times this area of the base we just found, 12.566, times the height, which we had to find it. Well, we didn't have to, but it's usually a good time to find it right at the beginning. 4.583. And again, I don't have to retype all these numbers in, already in my calculator. I got 1/3 times, and I want 12.566. There's 12.566 times, and then 4.58 all the way up here. So we get 19.195. And our units are cubic. Good. So yeah, if I should have read the instructions. It say nothing about the total area. All of the assignment problems, you have to find the total area, so can't hurt to have an extra example. Okay. And then finally, example 3 says if the volume of a cone is 187 cubic meters and the height is 14 meters, find the radius and slant height. All right, so we're given our volume and our height. Okay, so our volume formula, we call it as pi r squared h. Area of the base times the height. So we can go ahead and substitute in what we know. We have a volume, 187. We don't know the radius, but we do know the height is 14. And we want to solve this for the radius, for r. I'm sorry, volume equals, there's that 1/3 pi r squared h. 1/3 pi r squared h. Okay, so to isolate the r, we basically do the opposite of everything around the r, right? So let's start with the first term, 1/3. How do we get rid of 1/3? Okay, so let's multiply both sides of our equation by 3. Okay. How do we get rid of pi? How do we get rid of this pi? So what's the operation here? Between pi and r squared, what's happening? Okay, so what's the opposite of that? Okay, so we're going to divide both sides by pi. Okay. How do we get rid of the 14? Again, what's the operation? So how do we get rid of multiplication? Okay, so divide by 14 pi. Okay. And then we have a square. How do we get rid of a square? So square root both sides. Notice the order that I went in there. I want to be kind of clear there. I did multiplication and division before exponents. That's the reverse order of operations, right? Whenever you're working out a problem, you follow order of operations. Whenever you're solving an equation, you do reverse. You have to get rid of addition, subtraction first, then addition, multiplication, and then finally your exponents. Okay. So, well, all this stuff, notice what's going to happen. The 3's are going to divide out, right? Just to kind of walk through it. The pi's are going to divide out. The 14 is going to divide out. And the square and the square root undo each other. So all we have left is the r, all by its lonely. And that's equal to the square root of 3 times 187 over 14 pi. So square root, control divide, I keep the fraction bar, 3 times 187 over 14 pi. Okay, so we get 3.571. And our units here, our volume was in cubic meters, so our radius must be in meters. All right. And as for the slant height, so again, many times it's helpful to kind of just draw the cone, kind of wrap your head around what we know and what we need to find. Okay, so we now know the radius, and we know the height. Okay, so the slant height is that hypotenuse of that right triangle. And so our slant height must be the square root of 14 squared plus 3.571 squared. Square root 14 squared plus 3, oops, I'm use 3 point. I'm just going to press the up arrow, copy it down. I make sure it's still underneath my square root like I want it to be, and it is. And we get 14.44. Now, you saw me at least once forget the 1/3. It's really easy to do. So make sure when you're doing that volume that you write down that 1/3. That's why you want to write down that formula every single time. I just finished number 6 on the assignment. I finally remembered it on the first try. Okay, so just take trial and error. When you get a number, just look at it, just double check your answer, think about it, look back at your formulas. Okay, in this case, we have really 3 formulas that we're using. Okay, it's not like with pyramids or with prisms where we have to figure out what formula applies for the base. And this is always a circle, and so our formulas are a little bit just always the same. Okay. Questions or concerns? All right. There are 8 problems. The first 6 have the exact same directions. Find lateral area, total area, volume. That's it. Okay, those 3 things on all of them. Once you get to 7 and 8 on the last page, then that's going to be like the last example where you're given this, find that. By the way, that last example may help you if you were stuck on the last couple of problems from yesterday, because they were the same idea. Given volume and a radius, find the height, right? So it's the same idea. That may help you. So if you gave up on those yesterday, go back and look at them now. You've seen a specific example for them.